Hello and welcome to the 2014 AP Calculus BC exam question number 3. So basically in this question we're given a graph, and this is the graph of the function f. The function f is defined on the closed interval of -5 to 4, and the graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x is equal to the integral from -3 to x of f of t dt. So first we're asked to find g of 3, and g of 3 is basically just going to be equal to the integral from -3 to 3 of this graph here. So we'll write that out down here. The integral of -3 to 3 of our lovely graph f of t. And all that's saying is the area under the curve. So we calculate this area here all the way from here, and we're going to be ending at 3, so we'll calculate to there. So this first area, what this is going to be, it's going to be 6, and this is going to be 4 times 2 divided by 2, 4, and this is going to be -1 because it's under the graph. So we add that all up and we are going to get 9. So g of 3 is equal to 9. And that's part A. In question B, we are asked to find the open intervals where the g is both increasing and concave down. So this graph here is the derivative of g of x, and from that we can determine the double derivative to know when it's concave down. So what we need to do is we need to look at this and say we need it to be increasing, and we know increasing is when it's positive. So from here to here, -5 to -3, it's positive, so increasing. G of x would be increasing. -3 all the way to 2, and then the rest of it is not increasing. So it's not going to be 2 to 4. We know that, so it's not going to be that stuff. Now concave down. So how do we determine if something is going to be concave down? Its double derivative is going to be decreasing, which means that we're now looking at the derivative of this graph, basically. And this is increasing, this is decreasing, this is decreasing. We're only looking for when it's going to be decreasing like this, and not that. Looking for these two sections. So we have these two sections, and now we just need to write it down. So I'm going to write it down in interval notation. So on open interval from -5 to -3, as well as from 0 to 2. And that's a very bad parentheses, but you get my point. And that's question B. In question C, we are asked to find h prime of 3, and we're given that h of x is equal to g of x divided by 5x. So let's write this out here. And this basically just looks like it's going to be some calculating stuff. So we have this g of x divided by 5x, and now when we take the derivative, you just need to remember your division derivative rule. So what we do to find that is we have g of x, or g prime of x, times f of x minus now the derivative of this one and the normal of this, 5 times g of x divided by the bottom squared. So 5x squared. And now what we're going to do is we're going to evaluate this at 3. So remember that g of 3, as we discussed in the first one here, g of 3 is equal to 9. So we can start plugging some things in. We have 5 times 9, so -45 here. If we need g prime of 3, remember g prime is just going to be our graph here. So at 1, 2, 3, that's going to be equal to -2. This is a 45. Very hard to write. So we have a -2 here. and times 5 times 3 times, so that's 15. And on the bottom we're going to have 5 times 3, 15 squared, 225. And this is going to simplify down a little bit to negative 75 over 225. And if we look at this and think about it hard enough, we're going to get that it is equal to negative 1/3. It's an ugly 3. And that is h prime of 3. In part D, we're given that the function p is defined by p of x is equal to f of x squared minus x. And we're asked to find the slope of the line tangent to the graph p at the point x is equal to negative 1. So, to find the slope, we're going to define p prime of negative 1. So, let's write down p of x first. P of x is equal to f of x squared minus x. And from there, we can find p prime of x. So p prime of x, this is just some chain rule here, is going to be equal to f, let me fix that, that was horrible, f prime of x squared minus x times the derivative of this inner bit, so 2x minus 1. And now we're just going to evaluate when x is negative 1. So this is going to simplify down to f prime of, what is this going to be? F prime of negative 1 squared, which is going to be 1 minus 1, 2. And here we're going to have negative 2 minus 1, so this is going to be negative 3. So f prime of 2, we can find that here on the graph. So at this point, what is the slope? The slope here is going to be, what does this look like? Over 1, it's decreasing 2, so negative 2. So negative 2 times negative 3, and then that's going to be 6. So p prime of negative 1 is equal to 6. And that's part D. Thank you guys for watching, and I hope you guys have a great day.